8.2 Surface area of a prism. There are two key vocabulary words to know, and one little sentence that is really important throughout this section. So surface area. Surface area of a solid is their sum, which we all know is when we add stuff, the sum of the areas of all of its faces. And that is a key term from last section. And then a net is a two-dimensional representation of a solid, which is kind of when you unfold it. What does it look like unfolded? And then the surface area is a measure in square units. So we're going to be measuring things using square units. Our key idea is the net of a rectangular prism. And remember that a rectangular prism is a prism with rectangular bases. You do need to know the difference between a prism and a pyramid. It's really important that you do know that. So if you don't, freshen up on that from 8.1. This is a rectangular prism because if you think about its bases, which could be the ends or the top in this case because they're both parallel, and I'll erase this in a second, this is one base, and then the ground or bottom one on the floor would be that base. Okay, so with that being said, you kind of have an idea of what your base looks like and how to decipher what type of solid this is. So it's a rectangular prism. One thing you kind of need to know is that you have your length here, and then your height, and then your width. This would be your width, this is your length, and this is your height. Remember, you can find the volume of something that way and we'll learn more about that. When we want to flatten this and look at what its net is, so we want to find the two-dimensional representation of the solid, because that's how we're going to end up finding out what the actual the surface area of this solid is. So you're going to flatten it out like this, and it's going to kind of, once it unfolds, it would look like this. And you got to kind of imagine, where are these pieces at? What do they look like? And try to really visualize how you unfold it. So this right here would be where my width is. Okay, and that's what we represented right here. This is my length. So this is my long piece on my bottom, or, well, I should say on my side. It's kind of representing this piece right here. Okay, so that's my width. That's the box I just did. Then on top, so this one right here would be folded over, and when it folds, it's going to go right up here like this. Okay, then we're going to have a flap on the bottom that looks like this, which would be the bottom of it. And then we're going to have the other side, that's the exact same measurement of this one over here, so it's just the opposite one. And then it's going to go down, and we're going to have one more that's a little bit shorter, which ends up being one of the front and the side, or the front and the back. So this is our front, and I'll label these real quick. Okay, so you kind of have to understand here what pieces we're putting together. It is very hard to visualize, so don't feel like you give up because you're not sure what's going on. In class, we have the manipulatives that you can use to kind of open up and unfold and see what we can get out of it, and that will help tremendously. But you do need to understand like where these all come from. The next one I'll color code so it may be a little bit easier for you. Example 1, finding the surface area of a rectangular prism. So you have to find the surface area of the rectangular prism, and they give you your length, your width, and your height being 3 inches, your length being 7 inches, and your width being 4 inches. So now we have to put that into a net where we label the top and the bottom and the back and the two sides and the front. And then we can kind of figure out how big this rectangular prism is according to the surface area. So try to visualize how and where the top will be. I'm going to try and color code this a little bit, and then that will kind of help. So let's start with the top and the back. So if I have my top right here, and the top, bottom, and back, and I have my bottom right here, the part that's in the middle that's connecting the two is the back, which would be this right here, which kind of goes up, if you can visualize that. So I'm going to draw that out. I'm going to erase that first, but I'm going to draw it out and you'll kind of see where it kind of unfolds. So if I took this right here, this is my top, I'm sorry, this is my top here. This is my bottom, and what connects it is this back rectangle right here. So what I did was, let me get my drawing tool. I took this and I put it right here. And I took my bottom and I put it right there. And then my back, which is all this area, I drew it in here because that's what connected the two. Get my eraser. Now I'm going to fill in the rest of the number, or the rest of the sides, because then we can get the surface area. So imagine this side over here just kind of unfolding to become the side that's right here. And then this side, if you felt like it was cut and it just dropped open going this way, it would be right here. And that's another side. And then where does my front come into play? Well, my front is this area right here. And if you think about it, if this side opened this way, this would swing all the way open. So it would be put right here. Now there's a couple different ways you can unfold it and make a net out of it. But as long as they connect and they're in the right place, and I were to fold this up and visualize folding this up, it would create this rectangular prism. So now I'm going to add in the numbers. So we know that this length right here, or my width, is 4 inches long. And that happens to be on one of the sides. So we have to understand that this would become 4 inches right here. And if that's 4 inches, then this has to be 4 inches. And obviously the top, and you wouldn't have to label everything, but for the first time it might be kind of helpful. Then, looking at where these lengths would come into play. So this right here, this is considered a front. This is 7 inches. So if that's true, that means this is 7 inches. The top would obviously be 7 inches. And that would also mean that this number here is 7 inches, this is 7 inches, this is 7 inches. Those are all 7 inches. So then our next number comes into play, and that happens to be this amount up here, which we know our front, this would be our height, so this is our 3 inches. That's the most important part of this, so that you can start finding the area of things. And to find the area of things, it's kind of difficult because you have to really write everything out. So I'm going to do that over on the side here. So now you have to have all of these labeled top, bottom, front, back, side, and side. And then you need to put in the measurements for each of them. So let's look at the top. So we said that on the top, this measurement here was the same as this measurement here. So that means it's 7 inches. So we have 7, because we're finding the area of this. We have 7 times whatever this amount is. Well, looking at our entire piece that we have here, we have to try to figure out, is it the 4 inches or is it the 3 inches that would represent that side? So if you were to look back over here on your piece here, we have 7, okay, oh, I'm looking at my top, sorry. We have 7 times this amount right here. Well, if this is parallel to this, and this is 4 inches, then this is also 4 inches. So it'd be 7 times 4. That would give us the area for our top. Well, and if that's true, the bottom is identical, because it's parallel, so it's 7 times 4. Now let's look at our front. So our front is over here, and we've got this amount times this amount. So we have 7 times 3. You can see it right here is by 7, and up here my height is 3, so 7 times 3. My front is going to be identical to my back, so we just copy it down again. My sides, now I have this amount here, but I also have this side. So let's look. Here's our side. We have this bottom width is 4 inches. And then we have the height of it right here, which would match this one, which would be parallel to this. So it's 3. And that would be the same for the other one. Sometimes it is important that you know how to do a net. However, sometimes it's easier just to look on here and see where those numbers go, especially with a rectangular prism. Some of the other ones, it's a lot easier to unfold it, but you need to also know how to do that. So now we just figure out what these equal. So we have 7 times 4, which is 28. 7 times 4, 28. 7 times 3 is 21. Same thing. And then 4 times 3 is 12. Then you have to add them all together. I'm going to kind of go quicker, but it's 122. If you remember from the last page you were on, we talked about how surface area is measured in square units. So we're talking about inches. It would be 122 inches squared, and that would be your final answer of the entire surface area of this rectangular prism. I'm going to create 2 videos out of this one because the next example is just as long as this one. That way it kind of gives you a break and you can break it up. So the next one will be on the triangular prism, the net of a triangular prism.